मैडम, वो वाईफाई का कुछ तो प्रॉब्लम है लग रहा है, ऐसा है।
तर आपण लाईव्ह झालेला आहोत.
देखते हैं मैडम. ओके सर.
हां, तर आपण इंट्रोडक्शन करून सुरू करू शकता सर.
ओके.
ओके सर. बेस्ट विश टू यू.
गुड मॉर्निंग स्टूडेंट्स. शेयरिंग का ऑप्शन.
हाँ सर, स्टार्ट करिए.
जस्ट मैडम शेयर करना है मुझे स्क्रीन. आई जस्ट हैव टू शेयर. ओके.
स्क्रीन दिसते सर आपली.
ओके. स्क्रीन दिसते सर. स्क्रीन दिसते सर आता.
एस सर, एस.
यस सर. प्रेझेंटेशन दिसतंय.
ओके.
ओके. स्टार्ट करूं सर?
हो निश्चित.
एक मिनट सर जस्ट.
यस.
कैमरा सर थोड़ा सा सर, जस्ट कैमरा एडजस्ट करना है सर. Shall I minimize sir the camera?
हा सर, बंद करू शकता. प्रेझेंटेशन आहे तोपर्यंत, नंतर चालू केला तरी चालेल. ठीक आहे. आता बंद केला तरी चालेल. ओके सर.
आता बंद चलेगा ना? Okay students, good morning students. Myself is Mr. Vinay Kumar Prajapati and my colleagues with the Mr. Praveen M. Jamadar madam. We both are working in Kirti M. Dungarsi College, Dadar West, Mumbai, and we very thankful to Deccan Education Society as well as SCRT as well as my college principal giving me such opportunity to teach you. Okay students, so today we're going to start a chapter which is called as a set and relation students. So I will going to share my PPT to you. So we're going to start set and relation. So let us start with the introduction students. In everyday life, we generally talk about group or collection of a object. For example, bouquet,
सर, स्लाइड शो.
bunch, flock, family. Okay. Now it is okay, madam?
ओके.
Okay. So students, let me read once again the introduction for you. In everyday life, we generally talk about the group or collection of objects. For example, bouquet, bunch, flock, family for collection of different objects. We are well aware of that. Okay. Now, consider the following collection. First, successful person in your city. Then, happy people. Now, days in week. And next, first five natural numbers. So students, first three examples. Successful person in your city. So can we decide which people are successful in your surroundings? Then happy people in your town. Can you say that happy people in town? How many people are happy in your town? Clever in class. But if I say days in week, so obviously you will say there will be 7 days in week. Okay. Then first five natural numbers 1, 2, 3, 4. So what we can say, students, first three examples, not the examples of what sets, whereas last two examples, they will going to be nothing but they will going to represent set. So what is the basic definition of this set, students? So let us start with the definition of a set. A collection of well-defined object is called a set. Just in last two examples, students, if you have said collection of days in a week, okay, so you say that Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Okay, these are the 7 days in week. So that is properly what defined. Similarly, if you say the natural numbers in a days, so natural number in days, what students? So you say, sorry, natural numbers So natural number means what? 1, 2, 3, 4, 5. So these are already clear. So such collections will be called as a nothing but a set. So set is a collection of well-defined object. So now object in a set is called its element or a number. Whatever collections we are going to do in a set, they will be called as a element or member of the set. Just for example, if I say the first five, these will be called as a element or number of the set. Okay, so that object which will going to be collected. Similarly, we denote a sets by capital letters A, B, C, etc. We can use so many capital letters of English alphabet. The elements of sets are represented by whatever the things we are going to write collected inside the elements in a set, we are always going to denote by the small letters A, B, always. We denote sets by the set. They will going to write down by the small letters. Let us see the next slide. So, if X is an element of set A, suppose if X is an element of set A, we write it X belongs to A and it is read as X belongs to A. Next, if X is not an element of set A, we write X does not belongs to A and read as X does not belongs to A. So students, I'll just repeat once again for you. If any element which belongs to the set A, it is just read as X belongs to A. Whereas if any element which does not belongs to the set A, it is read as X does not belongs to set A. For example, 0 is a whole number but not a natural number. Okay, so see that how it has been written. 0 belongs to the whole number. Here W notation is used for the whole number, and 0 does not belongs to the natural number. Here N letter is used for notation as a natural number. Okay. Now, representation of a set. How a set can be represented. Okay. So there is the first method is roster method. So roster method is nothing but the list of all the elements of the set within the brackets and the separate them by a using comma will be called as a roster method. For example, B is the set of all days in a week. I have to use the roster method. I have to list. Just for example, if I say the list your friends or list your family members, you are going to be list that. Exactly the same way, students. If I say the B is the set of all days in a week. So how many days in a week you have to list them. So that is this. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And whatever when listing method, we have to write down the elements by doing what? Comma. So just see over here, I have listed the elements Monday, comma, Tuesday by using comma, Wednesday by using comma, and Thursday by using comma, and Friday, comma, Saturday, and comma, and Sunday. Okay. So this is the first method by which we are going to use what? Represent the set. Another example. C is the set of all vowels in English alphabet. C is the set of all vowels in English alphabet. How are we going to list them? We are well aware of that. There are 5 vowels. So A, E, I, O, U. So I have listed all the elements of English vowels. Okay. So this way we are going to use the roster method for the representation of set. Let us go for next slide. Set builder method. So that is another method for representation of a set. So let us see. In a set builder method, describe the elements specifying the property which determine the element of the set uniquely. Okay, let us understand by the example. Y is the set of all month of a year. Okay, now here what we had to do, that we had to describe the element of specifying the property which determine the elements of the set uniquely. Okay, Y is the set. So see, y is equal to x such that x is a month of year. Y is equal to, y is a set. Y is a set of the elements of the month of year. So y is equal to x such that whatever elements we are going to take, they should come from the month of the year. So that x represents over here uniquely the set of the month of the year. Okay, let us take another example. B is the set of perfect square of a natural numbers. So B is a set where we are going to have perfect squares of a natural number. Okay, let us write it in a set builder method. So B is a set where x belongs to the natural number such that x is a perfect square. So we have seen the two methods. One is a roster method and second one is what? Set builder method. I hope you different. In a case of roster method, we are listing all the elements, where in case of in set builder method, we are using little bit the shortcut method. You can say that. Okay, so writing, but here only one element will going to represent uniquely the whole set. Just for example, in both the cases, here x, in the first example, x is a month of the year. So x represents the unique property of that set elements and which give the month of the year. Similarly, in the next case, x belongs to the natural number and x is a perfect square. So x belongs to the natural number, so that x represents the unique property of that set issuance. Okay, now let us move ahead. Now, third method of representation of a set, that is the Venn diagram method. Okay, so that is, we can say, the factorial representation. How we're going to represent in the diagrammatic form, that will be called as a Venn diagram representation for a set. So generally, the geometrical closed figures like circle, triangle, or rectangles are used to represent the sets, which are known as a Venn diagram. Okay, so see, Venn diagrams, the elements of the sets are shown as a points enclosed in the diagram representing the set. So let us see by the pictures. Just these are the three sets, A, B, and C. We are having three sets. So in the first set, see that what we are, this the first is closed diagram, that is a circle, and the point, whatever points we have, 0.1, 0.2. So they are point. So we mention like points. Okay, 1, 2, 3. So in a figure A, the set has been represented 1.1, and set B, A, B, C, D, F, it is represented in the form of rectangle, and C, which has been represented in the form of triangle. So in this way, we have seen the three methods of representation of set. First is what? Roster method. Second is what? We can say set builder method. And third is what? Venn diagram method. By these three ways, we represent the sets. Okay, students. Now, let us move ahead. Let us see the exercise 1.1. Describe the following sets in a form. This is the letter of the word marriage. Okay, X is such that is a letter of the word marriage. Now we have to use a roster form. What is roster form? We have to go for the listing way. Okay, so we have to make the list method. So solution, just see, marriage, M-A-R-I-G-E, and always note that, students, in a set, no elements will going to repeat once again. Okay, so in just see that in case of the marriage, okay, here R has been repeated twice, but we have written one time. So while writing a set issuance, we should always take care of that. we are not going to be write down the elements to be repeat once again. Okay, so this is nothing but the listing. Let us see the next example. X, where x is an integer such that x should be less than -1/2 is less than x, and x is less than what? 9/2. If I see the -1/2, student, this can be written as 0.5. 9/2 can be written as a 4.5. So we had to list the elements which are the what bigger than the 0. B, the listing of what your set. So in a roster form, whenever we are going to write, we are going to write down the list element by using the what comma. Just see that I am list the element over here. 0 is the element by giving the comma. 1 is one element. So 2, 3, 4. हाँ हेलो मैडम आवाज आ रहा है?
सर
Can you hear me, miss?
आपका हवाई से ना समटाइम ब्रेक हो रहा है, तो थोड़ा सा
हाँ मैडम,
क्लियर कर दो. हवाई से ना आपका थोड़ा सा
ओके,
ब्रेक हो रहा है, थोड़ा सा हो
नेटवर्क
रहा है.
इशू रहेगा.
हाँ, बीच बीच
ओके,
में. हाँ, ठीक है, आप स्टार्ट करो.
ओके, okay, students, are you understood this? X is an integer where x should be -1/2 is strictly less than n. X is
आपका
less
वीडियो
than what?
सर, आपका वीडियो
9/2.
बंद कीजिए.
So we have listed by using 0, 1, 2, 3, 4. Now, next question is, students, describe. हाँ मैडम,
वीडियो ऑफ
हेलो,
कीजिए, उसकी वजह से भी कुछ तो प्रॉब्लम होता होगा.
वीडियो की वजह से मैडम नहीं, एक्चुअली नेटवर्क की इशू है मैडम, थोड़ा बहुत ऐसा लग रहा है.
ओके.
हाँ, क्योंकि स्क्रीन पे आ रहा है ना वाईफाई, वो नेटवर्क इज कनेक्शन इज लूज, ऐसा है.
ओके ओके, यू कैरी ऑन.
हाँ, ओके. Now, students, so next question is describe the following sets in a set builder form. So let us see the next question. So this is singleton set 0. Okay. Solution. So C is a set. Let us C is equal to some set X, where X such that X belongs to the W and X does not belongs to the natural number. But is W over here, it is a whole number. X belongs to the whole number, but X does not belongs to the natural number. Okay. So this is nothing but the set builder form. Now next example is 0, plus minus 1, plus minus 2, and plus minus 3. So solution is X such that here X should be what? -3 is less than equal to X, and X should be less than equal to 3, and X belongs to the Z. So here Z is what? Integers numbers. We know that -1 plus 1 plus 2 plus 3, they are belongs to what? Integers numbers. So here all the X, they will coming from the Z as the integers numbers. Okay. Now let us see the students next topic, which will be nothing but what? Intervals. In the first, we are going to see what? Open interval. Let A B belongs to the real number. Let A and B are the two real numbers, are the two numbers which belongs to the real number, such that, and A should be what? Strictly less than B. The value of A should be always less than B. Then the set, we are going to write X such that X belongs to the real number, where A is less than X, strictly less than X, and X should be strictly less than B, is called as an open interval, and it is denoted by open brackets A comma B. All the numbers, what is meaning of this, students? All the numbers between A and B belongs to the open interval A and B, but A and B themselves do not belongs to this interval. So in open interval students, in both the case, in this case students, A and B, these two elements, they are not going to belong to the interval, but in between whatever elements are going to be there, they are going to belong to the set. So that will be called as an open interval. So let us see that. Just see over here. This is supposed to be a real line. Okay. We have considered the two numbers A and B. So this, see over here, this dot indicates students, or just this open space indicates that A and B, they do not going to belong to the interval, but between all the numbers, between A and B, all the numbers, they will going to belong to the intervals. Okay. So in case of open interval, we always remember that students, the elements which are given over here, sorry, the numbers which are given in a bracket, suppose this A and B, they will not going to included in interval, while other elements in between, they are going to be included in a interval. So such intervals will be called as an open interval, and they are written like this way. So just see, in roster form, that open interval can be written as A comma B, X belongs to X such that R, where A is less than X and less than B. That is a, we can say, we have written in the form of what? Set builder method. Okay. So if you want to write down this in roster form, students, so what you have to do? We have to take the elements which are greater than A but less than B. We never take the elements one A and B in that set. Let us go for another interval, that is closed interval. Okay. So see, let A and B belongs to, let A and B are the two numbers which belongs to the real number, and A less than or equal to B, then the set X such that X belongs to R, A strictly less than X and less than equal to B will is called as a close interval, and it is denoted by, like in this square brackets, like this way. Okay. So it will be called as, it is denoted by the close bracket. So this will be a close interval. Let us see over here. All the numbers between A and B belongs to the interval including A and B. While in open interval we are saying that A and B we have to, we are not going to include in interval. While in this case A and B are also included in case of what? Interval. Such things are called as what? Closed interval. Okay. Let us see in the form of real line. Just see over here. In this case, over there we are having open space. Now here we are having closed. This indicate what, students? A and B both are included in the intervals, as well as in between all numbers will going to included in case of interval. Okay. So such intervals will be called as what? Close interval. So that can be written in the form of like closed interval a b x such that X belongs to the real number where A is less than equal to X and X is less than equal to B. In the case of open interval over here, we are having over here just sign strictly less than, and here we are having what? Less than or equal to B. That is one thing we should take care over here, students. Okay. Now we are having semi-closed interval. Now semi-closed. So just see semi-closed. See that here half we are having closed interval and half we are having open interval. So that's why it is called as a semi-closed interval. X such that X belongs to real number, A is less than equal to X and X is strictly less than B. Its meaning is that, students, A will going to be included in interval, whereas B will not going to be included in interval, but it between A to B, all the elements will going to be included in interval. Just see. Here A will going to be included, whereas B will not going to be included in the interval, whereas from A to numbers which are less than B, they are all going to be included in a B. So this set. Let us see another type of point, that is semi-open interval. See, semi-open interval. Here see, Now this part is open and this part is closed, students. Means we can say that A is not included in our interval, while after the elements which are going to come A, they will going to be included, but over here B also going to be included in our interval. Okay, so X such that X belongs to the R, A strictly less than X, and X is less than equal to B. Okay, so see, in this case, see, A is not included, whereas after the elements or the numbers after the A, they are going to be included in interval, and this B will also going to be included in an interval. So in case of these two, just see the difference between them, students. Semi closed and semi open interval. When I say the semi closed interval, just see that here A is included, B is not included. In this case, semi open interval, A is not included, B is included, students. Okay, in between all other numbers are going to be included in your interval, but when I say make like this way, so you do not include B, and this case when I make such a way that you do not include A, students. Let us see that over here. A and B excludes A but includes B. Okay, so similarly, what we can say over here, it includes A, excludes B. So that's a semi-closed and semi-open intervals. Let us move ahead. The set of all real numbers greater than A, that is X is greater than, strictly greater than A. The set of all real numbers greater than A. Okay, that is X is greater than A. So see how we can write down in the form of what? Set builder method. So open interval A infinity X such that real number X is greater than A. So X should be take the value greater than A, strictly greater than A. So when we draw on a line, just see that. So here A is not included, but all the numbers which are greater than A up to go for infinity. So that numbers are going to be included. See, this sign is known for the infinity. Okay. So here A is not included, but numbers greater than A, they can reach up to the infinity. Okay. Infinite numbers, such sets are called that infinite sets. Number of elements will be uncountable in this case. Okay, Shun? Let us see the next one. The set of all real numbers greater than or equal to A. The set of all real numbers greater than or equal to A. So that is C. Set of all real numbers greater than or equal to A. See here, greater than or equal to A. So if greater than or equal to A means it becomes what? Closed interval. Here we have strictly signed simply strictly greater than A. So that's why it becomes what? Open interval over here. See. So if it is included, so here A is included, infinity. So here it is not included. So go for infinite number. So this set we can say it is an infinite set for us. Now the set of all real numbers less than B. Now we are talking about the less than B. We are talking over here greater than A, greater than equal to. Now we are talking about the real numbers which are less than A, B. If you say the greater than A, students, so we are A to infinity. Okay. Now here it is less than B. So it is minus infinity. So we are going to count all negative numbers in this case. So just see. It's open interval minus infinity to B over here X such that X belongs to the real number. X is strictly less than B. So if you draw on a picture line, so just see that. So B is not included and up to the infinity we can reach. Okay. So we have three things over here. First thing, just see that the set of all real numbers greater than A. See, greater than A. Here we have greater than or equal to A. See the greater than equal to A. Now here it is what? The set of real numbers less than b, less than b, just see that less than b. Okay, students. The set of all real numbers less than or equal to b, that is minus infinity to c, less than equal to, so equal to b, so b is comes toward closed interval, so it is minus infinity to b. Okay, students, x belongs x such that x belongs to R, x is less than equal to b. So here b comes into closed interval, so b will going to be included, and all the elements which are going to be up to the minus infinity. So this will be the set. Now the set of all real numbers that is minus infinity to infinity. Okay, so here the set of all the open interval or real numbers, so it is minus all negative numbers as well as all positive numbers. See, minus infinity to infinity, x such that x belongs to R, minus infinity is less than x and less than infinity. Okay, so this is nothing but the set of all real numbers. See, only from here to here. Okay, so all positive numbers from right hand side of 0 and all negative numbers of the left hand side 0. So we cannot say that which number will going to be over. So since we have strictly less than sign over here, that's why since we have strictly less than sign, that's we have an open interval in this case. Okay, so that's why it is called as open interval. Now write the following intervals in a set builder form. So minus 3, comma 0. We have to write down this is in a set. This is an open interval. So first of all, just see that it is an open interval over here. If it is open interval, so we should have strictly less than sign. So see, the given interval is an open interval. So let us say a set A such that x such that x belongs to the R and minus 3 is strictly less than x and that x should be less than 0. Its meaning is that, students, we are not going to include minus 3 over here and 0 over here. In between, all the numbers will going to be included in a set. Now see, close interval 6 and 12. Okay, if we see the close interval, then what is the difference in these two questions? See, here I have open interval and here it is strictly less than sign. If it is close interval, then this should be have what? Less than or equal to b, because in open interval and close interval, what is the difference between we are having? In case of the open interval, we are not including the elements which are given. So here the number minus 3 and 0, they are not included in our set. When remaining all elements are included. Where similarly in closed interval, what happens? We include the elements which are given a set also. Okay, so just see. So the given interval is a closed interval. So A is a set x such that x belongs to the real number 6 less than equal to x or x is less than equal to 12. Okay, see that word difference. Here we are having what? Strictly less than. Here we are having less than or equal to, less than or equal to sign. So in this case, we can 6 and 12 both are included in a set, whereas this minus 3 and 0, they are not included in this set A. So whenever I want to list the element, suppose here it is given set builder form. If suppose it has given to be what? Write down in what? Roster form. We have to list the element. So what we are going to the list the elements over here? A is equal to minus 3 will not going to be included. So we have minus 2, minus 1. Okay, such elements we can list it. Okay, there are so many elements. Between this set, there will be infinite number of elements. Infinite number between these two numbers, minus 3 and 0, there will be infinite numbers. Similarly, between 6 and 12, we have to include 6, yes, 7, 8, 9, 10, 11, and 12. There are so many numbers in between them. Okay. Now, let us go for next topic, that is type of sets. We now are going to start the types of sets. We have seen this thing in our what lower classes, students. Just like in 9th standard, we have seen the types of sets. Okay, so now just I'm going to do the revision of these things, types of sets for you. Okay, so in the first case, we are having empty set. Empty set means what? No, nothing is in a set. Okay, so a set containing no element. A set contains no element is called as empty or null set, and it is denoted by the symbols or it is void set. Okay, so if the set contains no element, then it will be called as void set or empty set. Just see over here, A is a set X such that X belongs to the natural number where 1 is less than X and less than 2. So I have to find out this such a natural number between 1 and 2 which should be greater than 1 but less than what 2. There is no natural number such that between 1 and 2 there is no natural number belong, because 1 and 2 itself is a natural number. So there is no elements in a set A. That's why n of A is a empty set and it is number of elements is equal to 0 in this. So that why this set A will be an example of empty set. Next, singleton set. A set consists of only one element. Set containing only one element is called a singleton set. Let A be a set of all integers which are neither positive nor negative. We have to consider one set of all integers which is are neither positive nor negative. So I have to find out one number which is neither positive neither negative. Okay, so let us see. So obviously 0 is neither positive neither negative, so it consists of single element. So set consists of only single element, that is 0. So n of A is equal to 1. Such sets are called as a singleton set. Finite set. So finite sets means number of elements can be count from the set. So these sets are called as a finite set. Let us see by the example. Set in which the process of counting of element comes to an end as a finite set. If you count the elements which are given in a set and you can count by the ending, start from the end. So that set will be called as a finite set. Simply we can say the numbers can be counted from the set. So that set will be called as what? Finite set. So example, the set of letters, the words beautiful. Okay, so let us list them. See, we have listed over here B, E, A, U, T, I, L, F, U. Okay, so how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8. So we are counting. So the counting process end over here. So such sets are called as a finite set. Okay. Now students, let us go for the next. Infinite set. So I hope you understood infinite set. That process does not stop. We cannot count all the elements of the set. So that will be called as what? Infinite set. Set which is not finite is called an infinite set. Set which is not finite is called an infinite set. So just see that which is not finite, let's set of natural numbers. So there are so many natural numbers which means we can count. So this set will be not finite set. So that's why it becomes what? Infinite set. Now let us see the equality of sets. Now two sets are said to be equal if they contain the same elements. That is, the number of elements in A will be same as the number of elements in B, or number of elements in B will be same as the number of elements in A. So just see the example, students. Let X be the set of the letters in the word by A, B, B, A. So set X contains A and B, and Y be the set of letters word B, A, B. So Y contains the letter B and A. Okay. So thus the sets X and Y are equal sets and we denoted by X and Y, because see, the two sets are said to be equal if they contain the same elements. So see that same element here, A and B, here B and A. So the elements are same. So that's why these two sets are going to be said to be equal. Okay. So that is equality of a set issue. Now, equivalent set. Two sets A and B are said to be equivalent number of elements in B. See, इसके पहले now before that we have seen what equality of set. Okay, we have seen equality of set. In that case, elements are equal, A and B, B and A. Now here we want to talk about what number of the elements should be same. If in a first set suppose there are 8 elements and second there are 8 elements, so that 8 are same, that we can say that equivalent set. Let us see the example, students. Suppose A is a set. Number of elements are 4. Whatever the elements are there, we are not talking about here. D, O, M is there. But how many elements are there? 4 elements are there. Similarly, B, R, A, C. So see that if this remains the same number, same letters over here, so we can say that these are equal. But we are talking about the equivalent sets. Equivalent sets will be same when their numbers of elements are going to be same. So n of A is equal to 4, n of B is equal to 4. Okay, students. So such sets are called as an equivalent set. So here n of A is equal to n of B. Therefore, A and B are equivalent set. Okay, students. So now today we're going to be stop over here. Okay. Thank you, all of you students. Thanks. Thank you, students.
Thank you lots, Vinay sir. विनय सर, आजच्या
एंड करू अभी.
गणिताच्या संदर्भातलं छान माहिती मिळाली आणि त्यांचा अभ्यासक्रम उत्तरोत्तर चांगला होईल. आपले धन्यवाद आणि इथे आपण थांबू.